Hello everyone, I am Bhavani, Assistant Professor in the Department of IT at SMIT. Now we are going to discuss about the DBMS. We are going to continue with the balance topic, okay? See, already we have been seeing the course outcome syllabus, first unit relational database. Now we are going to continue with SQL fundamentals. See, actually SQL is structured query language. It is a standard language used to create and manage databases, and the data can be stored, retrieve, update and delete data, control access and maintain data integrity. It is mainly used with relational database system like MySQL, Oracle, PostgreSQL, SQL Server. Okay. SQL fundamental refer to basic concepts and commands of SQL. Okay. Used to store, retrieve and manage data in relational database. Now main components of SQL fundamentals, we will be discussing about DDL, DML, DQL, DCL and TCL. See, DDL will be data definition language, DML as data manipulation language, DQL data query language, DCL data control language and TCL will be transaction control language. DDL, it's a data definition language used to define database structure. Actually in this we'll be going to using the query like create, alter, drop and then truncate. See, for create it will be create database table and then view, alter modify table structure, while drop, using drop we can delete the database or the table, we can delete it. Truncate, it will be removing all records from the table. Example will be giving, see, create table as student. Student is the table name. In that we will be using roll number as an integer, name as varchar. We will be giving 50 and then age as integer. And then we are closing this. This is for create. Likely for alter, if we need to any changes that can be made using alter. Drop means you can use drop and the table name student. So drop student means the table will be deleted. Truncate means we can use truncate students means all records from the table will be deleted. Only the data will be deleted. And then moving on to DML, data manipulation language used to insert, update and delete data. In this we are going to use the command insert, update and delete. See, insert, add new records, update we can modify existing records, delete we can remove the records. See example, insert into student, values will be, see, student will be the table name and then the values will be given, 1 for serial number and then Ravi as name, 20 is for his age. Okay. Now moving on to DCL, data control language. Used to control access to data, will be using the command as grant and revoke. Grant is to giving the permission, revoke is to remove the permission. Example C, grant select on students to user 1. See, we will be using the grant is to give the permission what the person can be accessed. Revoke means what the permission we have been given, it can be taken back. Now moving on to TCL, transaction control language used to manage transaction. In this we will be using the command commit, rollback and save point. Commit will be save changes what has been made, rollback will be undo the changes, save point set rollback point. Example C, commit, if we have been any changes means we can save that. Rollback, if like we can see control is it what the changes has been made, we can get back what has been changed, so that we can use for rollback. Okay. And then we have one more is DML. I have been told you like DDL everything. Then DQL, data query language used to retrieve data. DQL is only for using command only select. Okay, other than that I told all the four. Select, you can give the example as select star from students. This is the only command select has been considered as DQL data query language. Now moving on to advanced SQL features. See, Advanced SQL features provide powerful data like retrieving, control, automation, and performance optimization compatibilities beyond basic SQL. First, it will be dealing with subqueries, like subqueries means nested queries, one within the inside, query inside the another one. Yeah, in this types will be single row subquery, multi row subquery, and then correlated subquery. And then you can let me explain you advanced SQL features or powerful SQL concepts used to perform complex queries, improve performance, ensures data integrity, and then automate database operation. C. Subqueries, a query written inside another query. Example, I can say you select name, okay, from the table student, where marks will be greater than select average marks from students, where we have been given select average mark from student. This is the inside the query, okay. Now moving on to correlated subquery. Inner query depend on the outer query, okay. Correlated query means there will be a inner query that will be depend upon the outer query. Then moving on to set operation. This is used to combine result of two queries. Operators description. See, first union. Union combine result, remove duplicates. Union will be combining the results, but it will be remove the duplicates whatever it is. And then union all, same, combine result and then also keep the duplicates within it. Intersects. See, this is common record in the table, okay. Except or minus, record in first query only. And then views. This is the advanced usage. Virtual tables, improve security and then abstraction. Create view. C. Depth view as select name department from students where department equal to CSE. This will be concentrate on CSE department, okay. Now moving on to embedded SQL. Before that, in this we can extra, I can say that regarding joins, used to retrieve data from multiple tables. Joins mean we need two and more tables, okay, not with the one table. We need maximum two tables to create a join. There are four types of join: inner join, left join, right join, and full join. And then stored procedures, pre-compiled SQL code stored in the database, okay. In SQL, create procedure, get students means it's the from table, okay. And then we can begin, select from students and then end, okay. And then we can see about the functions. User defined functions will be there, like return single value, and then triggers also there, automatically execute when an event occur. And then indexes, improve query performance. And then we can also see about the transactions and ACID properties, that will be ensure data must be consistency. Here we'll be seeing about atomicity, consistency, isolation and durability. And then at last we can see about constraints. You can know about the primary key, foreign key, unique, check and not null. And then we are moving on to embedded SQL. See, embedded SQL refer to the SQL statements written inside a host programming languages such as C, C++, Java or COBOL. It allows program to interact with a database directly while executing application languages. Simply I can say that is a technique where SQL statement or reside returned inside the programming languages, okay. Likely all statement to be embedded within a host programming language, enabled to access and manipulate databases. And then we can, let me say why embedded SQL is needed. You have the question. So alone SQL cannot be handle the logic like loops or condition, and then programming language cannot be directly access the database. So embedded SQL combines SQL plus programming language, so only embedded SQL is needed, okay. Now see, architecture of embedded SQL. This will be the architecture. First will be host the program. Program means it will be written in the language. C or C++, Java or COBOL. And then embedded SQL statements, pre-compiler, and then DBMS runtime. See, structure of embedded SQL, let me tell you. SQL statement are written using EXEC, execute SQL like that. Variables are shared between program and SQL using host variables, okay. And then key components will be like pre-compiler, host variables, embedded SQL system, statements, and then host language, which I told before. Advantages, see, it will be highly in performance, strong integration with programming language, efficient transaction handling, secure and reliable. Disadvantages, see, less portable, DBM is dependent, okay. Harder to debug. For debugging, it is very hard. Requires pre-compiler and then complex and then application of embedded SQL. C. With using embedded SQL, the application has been produced likely first banking system. It has been used in banking system, reservation system, enterprise application, financial software has been made from this. And then we are moving on to dynamic SQL. Dynamic SQL refer to SQL statements that are constructed and execute at runtime rather than being fixed at the compiler time. Then we see why dynamic SQL is needed. This is the method in which SQL statements are constructed and executed during program execution, allowing flexibility in database operation. See, when table name, column name or condition are not known in advance, for user driven queries and to build the flexible and interactive application. Then the characteristics of dynamic SQL. SQL statements are prepared at runtime, more flexible than the static SQL, slightly slower than the static SQL, used with the host languages. See, host languages will be C, Java, PL, SQL, etc. And then what are the steps used in dynamic SQL execution will be construct SQL string, prepare the statement, bind variables, it is optional, and then we can execute the statement, okay. And then advantages will be highly flexible, support runtime decision making, useful in complex application, allows the dynamic table column access. Disadvantages, same, harder to debug, performance overhead, complex coding, security risk, and then slower execution. Let me explain you this dynamic SQL in single line. See, it is the execution of SQL statements that are created at the runtime rather than the compile time. Okay, thank you.